As Anne said, I'm probably not going to have any time for taking questions, and that's due to exceptionally poor time management skills on my part. They're just integrated in my being, which is going to be a little bit ironic, given that I'm actually going to talk a little bit about time and how we manage it during this talk. I am no stranger to irony. What are we talking about? We're talking about technical neglect. My name's Kelvin Henney. I happen to have a fairly unique name, so yes, you can find me on Discord. I'm also around all day for those questions. I think Anne said that any questions it might provoke. Yeah, I think it will provoke a few questions. Life used to be easier, but since the balkanization of social media, you can find me online, okay? I used to just put my name as @Kelvin Henney, and that was kind of easy, but it's just got ridiculous. So yeah, just I am contactable and findable and photographable and all the rest of it. So I'm going to give you the short version of the talk if you want to fall asleep for the next bit. I don't know how far you've traveled this morning. So what do I want to talk about? I want to talk about time. I want to talk about a slight problem that we have in software. We often conflate cause and effect. We confuse the cause with the effect in some cases and bang on about the effect. The one I want to focus on today is technical debt. A lot of people talk about technical debt. I have no idea why they're talking about technical debt. They're spending their time talking about the effect. In most cases, what they actually want to be talking about is technical neglect. Debt is a consequence. You don't have a debt problem, most likely you have a neglect problem. Yeah, you've been distracted. It's a classic magician's trick. Look at this. Magic happens over here. Except in this case, it's really dark magic. But I also want to go through and explore some of the words and concepts that we use, because even when people say we have a technical debt problem, they're not really quite right, even with that, in terms of describing the effect. The words we use shape the way that we think, and I'll be exploring that a little bit. But let's actually just dig into it. So that's that. We're kind of almost done with the intro bit. You can fall asleep now. So this kind of relates to something I noticed a few years ago. I'm an independent consultant and trainer and stuff. I've worked for myself. This century actually, it kind of rounds nicely from in terms of years. I'm based across the bridge or bridges in Bristol. As you may notice, there's an awful lot of water between here and Bristol. And one of the ways we could do this without bridges is with boats. And it was something that occurred to me a few years ago, visiting a client who I had visited before, and they'd said, Kelvin, we've got all this kind of like stuff, this code that's messy. We've got this technical debt problem. We've got this kind of legacy thing going on. We've got all of these issues in our code. What can we do about these? Obviously, they're looking for a quick fix, okay? There is a massive shortage of silver bullets. There are no quick fixes to this. RM minus RF is a possibility. That's the kind of classic movie, explosion goes off behind you, you don't even look back. That is a possibility. I'm not necessarily recommending it here. I don't want to get sued by any particular organization for that. But one of the things, and I noticed it here and in a couple of other places, we ran workshops on legacy code. Hey, what are the situations? What are the hot spots? All the cold spots in your code base? What are the issues that you're experiencing that really slow you down or cause frustration at a personal or team level? And then we kind of offered some remedies. We talked a bit about software craft and a whole load of stuff. And you should do some more testing. Testing, the lack of testing or lack of decent testing is slowing you down. All of this kind of stuff. But the funny thing is, a couple of years later, they kind of made some progress, and then they didn't. And it was this that I started realizing there was a pattern of behavior, which is why there's a boat here. I want you to imagine that you are in a boat, and there is a hole. In fact, maybe there's cracks and multiple holes, and you're taking on water. What do you do? Well, one thing you can do is, we could borrow one of those lightning talk buckets, use one of those. Toss out the water. Scoop it up, toss it out. Is that Is that all you're going to do? Well, no. When I put it like that, the metaphor is quite obvious. The other thing is you have to attend to the fact that there's holes in the boat. I mean, you've got to get really good at bailing water out, but that's not the whole skill you want to develop. That is very much the sound of one hand clapping, okay? You've missed the point. You need to stop the water coming in. And what I've experienced is in a number of organizations, when they do kind of get serious about, yeah, we're going to deal with our unmanaged technical debt, what they forget to do is to stop producing it in the first place. Most organizations, let's fix the problem, but they don't fix what causes the problem. So they're busy producing new crap whilst they're busy fixing the old crap. You can reach a steady state in this, if you're lucky. In the worst case, it all slides downhill. So, is this a problem? Is this inevitable? Well, yeah, it is kind of inevitable. It's not that we don't know what to do about it, we do. And there is this observation from Meyer Manny Lehman in a classic paper from 1980, just to give you a sense of how new this information is, okay? And actually, Lehman was saying this through the 1970s, if you read his earlier papers. Classic paper, Programmed Life Cycles and Laws of Software Evolution. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. There is no ambiguity. He's not beating about the bush here. He is telling you something that you already know. But he said it 43 years ago, or in fact half a century ago, if you go back far enough. And if you think about how much software we have now compared with how much software we had then, he was working with a relatively small sample size. And he could have been wrong, but he wasn't. It turns out he was massively right. Now, what do we call, let's just think about this. As an evolving program is continuing to change, its complexity reflecting the structure deteriorates. In other words, as we do work for other reasons, somehow the existing work gets caught up in that. It gets caught up, our existing assumptions, any shortcuts that we've taken, our past misunderstandings, because we're always working with incomplete knowledge. We'll never produce a perfect solution. We're always working with incomplete knowledge. All the knowledge that we need to do the work we are doing today is in the future. Yeah, this is unfortunate, but it is a fact of physics, okay? And then he does something very careful here. Increases unless work is done to maintain or reduce it. What do we call this process that he's describing when we deal with physical objects? We call it maintenance. That's the thing we don't do very well with software. In fact, it's even worse than this. We've taken the word maintenance and completely misused it. When people talk about software maintenance, what they actually mean is fixing bugs. That's not maintenance, that's fixing bugs. You're not maintaining it, you're trying, if you maintained it, this is bug for bug compatible with the last release. We have preserved all of the bugs, we have maintained them, exactly. That, we have misused the word. And the other one I love is just like, and I deal with teams, it's like, this was developed over here, and this team, and then it was moved to another country, another site, and these guys do maintenance. Oh, what does that mean? Oh, it means they add new features. No, that's called software development. That's called adding new features. That's called continued development. The word maintenance has a really simple meaning, and somehow, one job, we screwed it up. Maintenance, that's what code needs. We need to maintain, otherwise we get overrun by its complexity. So the problem here is we have somewhat misused the terminology. So I kind of like words and language, and I have a number of dictionaries on my machine and physical dictionaries at home, and it's about the only piece of software I install whenever I get a new laptop is I've got 3 dictionaries, including the Oxford English Dictionary, which, if you were to print it out, it's far too large. But I have this, and it's always a bit of a challenge when I get a new machine, because I have to find an optical drive somewhere in the house. And, and it's just, I know I've got one somewhere, and it's just like, yeah. But the OED has the breakdown of this. We're using metaphors. Now, this is the whole thing. Metaphors are incredibly powerful. This idea, what is a metaphor? A figure of speech in which a name or descriptive term is transferred to some object different from but analogous to that which it is properly applicable. In fact, that notion of the word transfer, that's actually where it comes from. The Greek metaphora, that's what the verb means, to transfer. And there is an idea here that metaphor is not simply something that you study for GCSE at school when you're doing English language. It is something much deeper. It is not simply about poetry. And the work of Lakoff and Johnson at the end of the 70s, this book was published in 1980, Metaphors We Live By, was quite groundbreaking in many respects, because what they said is, they said, yeah, metaphor is not about poetry. Metaphor is not about flowery language. Metaphor is actually fundamental to the way that we think, to the point it informs how we use the little words, the prepositions. It informs how we approach things. It's pervasive in everyday life, not just in language, but in thought and action. The essence of metaphor is understanding and experiencing one kind of thing in terms of another. Obviously, we have to do this in software, because most of the stuff we do is, quite frankly, just made up. It's not real. Or the way I tend to put it, it's just not kickable. Even though that's the feeling you might sometimes have, a desire to kick, and yet there's nothing there. So it's unkickable stuff, yet we describe it. And there are many, and importantly, this is not just a point of vocabulary, it's about systems of thinking. In this book, Lakoff and Johnson describe a number of metaphors which will be familiar to you. Time is money. Okay, that's not just a saying. It also, if you pause for a moment, it informs how you use certain words. For example, you are spending today at PyCon. Spending. What is that the language of? That is the language of money. It is not the language of the physics of time. It's the language of money. We talk about wasting time as if it's something valuable. Oh, value, there's a thing that comes from money. These are all connected. Argument is war. Yeah? He attacked her argument. She defeated his argument. That's the language of war. That's the language of conflict. But we also have other ways. We sometimes approach something from multiple perspectives. Arguments are buildings. Okay? His argument collapsed. Okay? Well, that's a description of structure. Okay? Her argument had a strong foundation. Okay? We use this language. It is informing. It is shaping. This is actually quite important because when the minute you start looking for it, you go, oh my goodness, it's absolutely everywhere. And there's this wonderful thought. It's a friend showed me a picture. It was just like, oh yeah, here's my partner in front of the mountain. Mountains don't have fronts. That's us. We have fronts. We have backs. That's a back. That's a front. We are describing something that is symmetric and has no sense of direction or personhood in terms of something physical to do with human bodies. This is all over the place. The minute you start looking for it, it's like, wow, it is everywhere. It's also culturally specific as well. Some of these are narrowly culturally specific. Some of these are broad. Some of these are linguistically specific. Some of these are broad across the language family. Happy is up, sad is down. How are you feeling? I'm feeling down. I'm feeling up. Upbeat. We don't even think about it, but quite clearly, up and down these are physical directions. These are spatial. They are vectors. And yet somehow we're relating them to mood. Yeah? I can imagine quite easily a culture where the opposite is true. Where down is happy because you're grounded. You know where you are. Whereas up is sad because it's chaotic. It's up with the weather. Okay? So it's very easy to understand that these are utterly arbitrary, and they're based on creating a framework. Love is a journey. Okay? Where is this relationship going? Relationships don't go anywhere. They're not a thing that travels. You can't put an odometer on them and just kind of like check it out, you know? Oh, wait a minute, let me get the GPS on this. I've checked it on Google Maps. I can't find our relationship. So the point is, we use these as a frame of reference. We take something that is abstract or complex, and we reframe it to explain it in terms of something familiar, and often, particularly with these, physical, because we're physical beings. So therefore, that's our starting point. And this is an observation I made when a few years ago co-authored this book with Frank Bushman and Doug Schmidt, Pattern-Oriented Software Architecture on Patterns and Pattern Languages. I'd love to say that this is the book, I've actually had people say, oh, should I read this book if I want to get into patterns? No. This is the book that you read after the previous book that you got that was recommended to you by somebody who then recommended another book as your starting book. This is your third or fourth book. If we haven't shut you up and confused you by this point, this is the book you want. This is all the pattern theory and weird stuff and edge cases and philosophy. Why did I write such a book? Because we needed somewhere we could point to. When people ask certain questions, yeah, we wrote about it. Okay. So, but we also talked about the nature of thought stuff and software. The aphysical, invisible domain of software is more about metaphor than matter. This point was also taken up in Andy Hunt's book, Pragmatic Thinking and Learning, where he, unfortunately in the subtitle, misuses the term refactor. Refactor your wetware. It sounds kind of cool. We're going to talk about refactoring in a bit, but the first thing I'm going to tell you is the whole point of refactoring is that you do not change the observable behavior of something. The whole point of this book is you change your behavior. So it's kind of not refactoring. It's rewiring. It's the whole problem we have with the word maintenance, yeah? However, he has a really nice section on metaphor. As he points out, what we call windows on the computer screen aren't really windows at all. They give us a systematic vocabulary. They give us a way of thinking about it. When I talk about a window, I can talk about opening and closing it. Well, that's the vocabulary of Windows, okay? When you talk about a window, you don't start the window. That doesn't really kind of make sense in that sense. You don't connect to the window. Connection and disconnection is not the language of that thing, okay? Of course, a metaphor is not going to be perfect. By definition, a metaphor is not perfect. So whenever anybody says, oh, that's not that metaphor is not perfect, well, of course it isn't. That's because it's a metaphor. If it were perfect, then it would be identity, because it is the thing. Yeah, cut the poor metaphor some slack. Of course, it's not going to be a perfect mapping. Have you ever tried resizing a window? My God, my wife and I have done it on 2 houses now. It's a very expensive process. Yet you do it all the time. What about minimizing a window? Okay, so, it's not perfect, but it gives us sufficient alignment because it also gives us a system of thinking. We talk about views. There's the whole language here. When we think about this, folders, it's not a real folder. Trash can isn't a real can. And in fact, there's also another interesting thing. We sometimes find that you can tell that Andy is a Mac user. I'm a Windows user. We have a recycling bin. Why do we have a recycle bin rather than a trash can? Is it just intellectual property? No. It's because metaphors change, because they capture a moment in time as well as a concept in space. When the Mac came out in the mid-'80s, recycling was really not a thing. You had trash cans, but hit the 90s, oh yeah, we're all about the recycling. It's actually a more accurate metaphor than the trash can. Okay, more likely your recycling is in a far better condition than your trash can, especially the one they show you that's outside and caught in the rain. Maybe it's California weather that makes them think this is a sensible metaphor for putting things in and then getting them out again. It's a terrible, terrible idea, okay? But we also have other ones. When you write concurrent program using threads, you're not sewing. But hey, this is a Python conference, so we don't have to do anything about threads. I was actually contacted year 1 of the pandemic, I think, and it's like, hey, would you like to, Kelvin, we see you do some Python stuff, and we see you've done a whole load of stuff with concurrency in various languages and paradigms, and we're putting together this kind of like team-written book, and we'd love if you could contribute a chapter on threads in Python. And I said, it's going to be a really short chapter. It's going to be don't do it. And that's it. I mean, if you want to pay me for that, I'm happy to go with it. Don't do it, but if you think you know better than me, here's the link. That's it. That's the extended version of the chapter. Python is uniquely unsuited. I cannot think of any language, not even JavaScript, that is actually worse suited to threading than Python. That's not how we do stuff. Nonetheless, these things exist in other languages, so we can talk about them. It's just a metaphor. So, this is this point about quality that I was coming to. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. There's a second condition as well. Another quality of a good metaphor is it should not have too many obvious points of conflict. If it's like way out of whack and you keep having to apologize for it or compensate for it, that metaphor is not really doing the work. You are. The third one is it should be familiar. It should have some familiarity. Otherwise, the whole point, I'm going to explain a thing that is abstract, complex, and unfamiliar in terms of another thing that is totally unfamiliar to you. That's not going to work. It's going to be a lossy transfer, okay? So you have to rely on that, which means sometimes a metaphor is dependent on its target audience. Now, it's time to talk about legacy code. This is one of the classic legacy computers that we know of. We're not entirely sure who built it. We don't exactly know what it does, but it seems to work twice a year. The original developers left a long time ago. The intentions are lost to us. Legacy. When we talk about the term legacy, that is a metaphorical thing. But somehow we've managed to subvert it and reverse it. Legacy is normally supposed to be a good thing. We also talk about spaghetti code. That's a structural description. The problem is that it's not very, as a metaphor, although it's created a system of metaphor, that was not its original intention. Because now you get people going, oh, you don't want spaghetti code, you want lasagna code, nicely layered. Or ravioli code. And what I love about the ravioli code is that each generation discovers it as a new idea and thinks it's their own. So the latest one is, you want ravioli code? Oh, what, you mean microservices? I first heard this back in the early 90s when people were saying, oh, it's about objects, and then it was about components, then it was about services, and then it's about these things called microservices that are even larger than the services that were just called services. We really screw with language something terrible, don't we? And if you like pasta, then spaghetti is not a bad thing. I love spaghetti. Of all the forms of pasta, it is still my favorite. Code rot. That seems to be getting a little bit closer, but the problem is rotting is a natural process. It's a process of decay. Okay? We have these various terms, and if you have this terminology, then it's the idea, well, hang on, if I leave that code alone for a while, I come back and it's just like, it's a bit moldy, isn't it? I just left it in Git for a week and it's gone off. I didn't realize there was a use-by date on it. It's a natural process. The problem is that this is more like something that is left in a vacuum. You leave it alone, nothing happens. The rest of the world moves on and perhaps renders it superfluous, but it does not change. It's not a natural process. I'll have to admit, I did a physics degree, my first degree, and I always thought entropy was a really good way of describing this stuff, because it's a measure of the disorder. And in fact, it actually works with layman's wording about you have to put work into it. I think it's a really good way of doing that. It turns out, however, not everybody knows what entropy is. And that was when I first discovered that there were a group of us at the company I was working who were all basically physics rejects. It turns out this very popular software is a great destination for physics rejects. Any other physics rejects here? There's a few of you, yeah. I see you. And it turns out there was a little cluster of us. So we were all talking about this, and then we went to speak to somebody who had a pure business background, and they just looked, what the actual? Entropy. I have no idea what you are talking about. You know, like in physics. Or maybe computer science, you know, information theory. Nah, you lost me, mate. So, joyful and accurate as it might be, not a good metaphor. Technical debt. Oh, we're going to come to that one. Unhedged call option. What? Okay, this is one from Steve Freeman, and I think it's really interesting because he's talking specifically about bad code. And here you suddenly get that real sense. He works with financial programming a lot. If you are in this space, you might go, oh, I get it. The rest of us, please explain what an unhedged call option is so that I can understand what this other thing is, and you'll actually discover it's not going to help. Housework. Oh, I like that one. We're going to come back to that. So here's the thing. Let's go into the dictionary again. Legacy. The nice thing about the OED is that it's completely useless as a usage dictionary. If you want to find out how to use a word, if you want to find out how you could or should be using it in speech, do not use this dictionary, because that's not what it's for. It's a historical dictionary. It'll tell you the uses and evolution of the word for the last 500 years, in that order. So you will start off with the most archaic term. If you want to spice up your language, this is probably a good way to go, but generally not otherwise good. But here's a little addendum. 1989 is when the term legacy was first recorded in software and technology, which I think it feels really young, given that we clearly have had the problem for a while. What did we call it before? We just shrugged our shoulders and said, well, that's a bit of a problem. But we didn't have a systematic way of describing it, even though laymen have been going on about it for years. So, yeah, I think it's quite late. Some people might think it's if you were born after 1989, you're thinking like, wow, that's prehistory, man. That's like next to the dinosaurs and, not having mobile phones. Now, of course, am I even doing a talk in 2023 if I don't mention AI? Here's the AI slide. This is the interesting thing, that what we may end up with, because why is this here? Legacy code. I've used the term here, but this also speaks to a problem of neglect. The practical consequence of using large language models to generate code is many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code and have redefined their job as debugging and fixing such code, which we often call maintenance. Because what you've done is you've created code that somebody else wrote. That is exactly what we call legacy code. It's the standard developer. And having run legacy code workshops, I ask people, give me some different definitions. Serious, humorous, whatever. One of the ones that turns up every single time is code written by another developer. Code written by someone else, that's legacy code. Guess what? We've just automated the creation of legacy code. Yay us. Yeah, that's a bit of an own goal. Just a reminder there. I'm not saying everybody who's using AI is going to screw it up this badly, just most people. Okay? The majority, based on Sturgeon's law, will find themselves doing this. So let's talk about technical debt. Now, technical debt was not a term created by Martin Fowler, but it was popularized by Martin Fowler. It's a wonderful metaphor developed by Ward Cunningham, perhaps better known as the inventor of the wiki. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. Now, this term was, the debt terminology was used throughout the 90s. It was introduced by Ward in the early 90s. But it didn't really take off in popularity until the early 2000s. Partly, Martin was responsible for helping popularize that. But we have a small problem here. It's a very subtle one of language. All through the original version of this blog, he keeps referring to the quick and dirty way of doing something. Quick and dirty. That is not actually, well, first of all, that's not a very positive phrase. You're definitely saying that when you're doing this, it's not a good thing. Okay, quick and dirty is not a thumbs up, yes, that's awesome. It's not a positive thing to say about it. Just that subtle choice of words actually has this very long-standing influence. When we actually look at what Ward did say back in 1992, he was looking at it from a very different point of view. He wasn't talking about it being dirty. He wasn't talking about it being bad. This is not clean versus dirty code type thing. He said shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. He was trying to get you to understand debt as an act of borrowing. The ability to achieve something that you might not otherwise achieve. The idea that, if I borrow this, if I borrow against myself, if I borrow against the project, if I borrow against the work that we're going to need to do, I can get a short-term advantage. Sometimes I can do that to find out what the users actually want, or whether or not this technology is even a good starting point without really fully investing in it. The whole point is he was using this as a deliberate design trade-off. The idea that you don't want to overcommit to something. The idea that you're exploring something. The idea that you may have other reasons to do this. In the real world, we also recognize that this is one of the reasons we have debt. The ability to achieve certain things. Of course, debt can run wild and out of control, and debt can be frustrating, but you get a benefit from it in some cases. A number of you in this room will have a mortgage. Okay, just remind you, mortgage, M-O-R-T, death. You know, it's a very positive term there. But what you get, that's a whopping great debt. But what about it? I mean, obviously, we'd rather we didn't have it. But if you've got a mortgage, that's structured. There's no surprises there. People aren't coming around with brickbats, you know, demanding things at random times of night. It's structured, it's controllable, it's knowable. What do you get in return? A house. Yeah, that's a bit of a win. So the point there is there's a direct trade-off. You are making a deliberate, intentional trade. That's what Ward was talking about. That's the point of the debt metaphor. Of course, we also know debt has a darker side. And he points this one out. He talks about this as a danger of debt. He's not saying, so the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. So sure, code that is messy, code that is neglected, does constitute debt, but so do other things. It's not necessarily bad. The debt metaphor does not mean, hey, this is bad. So this is a point. Now, sometimes people get a little bit carried away. I wrote this piece for O'Reilly Radar a couple of years back on exactitude and technical debt. Although we know by definition no metaphor is perfect, there are two common ways the metaphor is misapplied. The first one is assuming technical debt is necessarily something bad. Just like with real debt, it's not necessarily bad. There's debt that was intentional, deliberate, and prudent in its application. And equating technical debt with a financial debt value. That's the whole point of a metaphor. It's not financial debt. It's kind of like it. It gives us a vocabulary and a way of thinking. But there are actually tools out there, and perhaps you've encountered them. I'm not going to name any, but one of them begins with S and ends in cube, that actually will try and give you a financial figure. It will do a static analysis of your code and then say, hey, guess what? Your code has £50,000 worth of technical debt. There's a technical term for this. It's called bollocks. This is the worst. This is not even homeopathy. This is so bad in terms of science. It should not even be allowed. It is just a false claim. Well, there are a number of reasons it's a false claim, but that is not, you cannot say that about the code. It's a metaphor. Just stick with that. It's supposed to give you a system of thinking. So we end up with this, talking about it. But the first thing, and the way that I've clarified it over the last few years, is most people, when they're talking about technical debt, actually mean unmanaged technical debt. And if that's what you mean, you should say it. If somebody says, hey, we got lots of technical debt, is that a bad thing or a good thing? I don't know. So I've had this experience as well at companies where somebody will say, you know, I'm running a workshop, and they say, oh, yeah, our problem is we have technical debt, lots of technical debt. And I say, well, why is that a problem? And they look at me like I'm a complete idiot. I'm not going to exclude that possibility. I have children that do the same thing. But what I'm trying to get people to do is say what you mean. Sure, you've got technical debt, but are you managing it? Because I want to hear the words from your mouth. I want to hear you say, oh, yeah, the problem is we actually don't manage our technical debt. Right, there you go. Now I want you to tell other people that, because it makes it really obvious what's going on. It's not that you have technical debt, it's whether or not it's managed or not. And what are the consequences of this? If a codebase has unmanaged technical debt, there are a number of things that are likely to be harder than necessary. Staff retention, that's a good one. Security, compliance, defects, development, tracking changing markets, requirements, technologies, etc. It turns out there's a number of things that become unnecessarily hard. One of the ones I quite like pointing out these days is security. This is how I get people to focus on code quality, because everybody cares about security now. Because you can't make the claim, we're on top of security. Yeah, we take a lot of measures. We take security seriously. Okay, let's talk about this part of your code base. These modules here. Oh, we have no idea what they do and who wrote them. Okay, the claim that you don't know what this is, but you are secure. These two sentences do not match up nicely, okay? Security, one of the things about security is it's about knowing, and it's about knowledge, it's about knowability. If you say there's a whole bunch of stuff, we have no idea what it does and the way that it does it, then you're basically saying there's potential vulnerabilities here, there's potential faults here, we have no idea. Yeah, that's what you're saying. So there's a number of, when you start taking a step back and looking at the language we use, you're kind of like, oh yeah, actually that is a point. The other thing that I sometimes get when having said, by the way, technical debt, you shouldn't mistake it for being equal to financial debt. You shouldn't be hunting around for a number. Some people come up to you and say, oh no, we do have a number. But the number is ours. And perhaps, we can deal with that. The number is ours because what we've done is we've estimated how much technical debt we have in the codebase. Or to be precise, how long it would take us to fix it. Now, let's be very clear. That is the cost of repaying the debt, or it's an estimate of the cost. The debt metaphor is about the cost of owning it. That's not the same thing, okay? If you have a debt that you can pay off today, the whole point of the debt metaphor was not simply what you pay off today, but what has it cost you in the past? The point of the metaphor is a measure of the specific work needed to repay the debt is not right. It is the additional time and effort you put in the past, today, and if you don't deal with it today, the future. That's the whole point. It has an interest rate, and you have been paying that. That's the idea. It's not the repayment cost today that is the debt. It is everything you've experienced in the past and will experience in the future. Now, let's go back to housework. Yvonne Lamb had this one, which I absolutely love. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt. We can't use it because tech has been made up of people who don't do housework or manage housework being done. Nailed it. But she's raised another point. She's come back to that point that we had before. What she's talking about, what is housework? Ultimately, it is maintenance. But maintenance is an action. What we're interested in is the inaction, for which we have a name. Neglect. Want of attention to what ought to be done. The fact of leaving something undone or unattended to. Negligence. We use the term in many contexts. We use it in terms of buildings. We use it in terms of upbringing, physical neglect, emotional neglect, and so on. Neglect is not a thing that happens. It is a thing that does not happen, which is why it's sometimes so hard to see. That's why we often don't find the cause, because it's a thing that doesn't happen. We see the effect, but the thing that didn't happen is not visible to us. It's not just that the dog didn't bark in the night. It's the dog didn't even get up and boot up the computer. Okay, that's the key thing. We don't see the thing happening because there isn't a thing. Now, there's a really interesting thing. I talked about, you used the word value earlier on. It's a really interesting way of thinking about what it is that we are doing when we are doing any kind of coding. If you're sitting there and you're looking at some code, you're doing anything to do with the system, let's use the language of supply and demand. There's a demand for your work here. What is that? What is the cause of that demand? This guy, John Seddon, not a software guy, but a systems guy. He's been involved in a number of organizations, this country, NHS and stuff like that. And he partitions demand into two types, value demand and failure demand. Value demand represents the demands customers make for the things they want, the things that are of value to them. So why am I here, sitting in front of the keyboard? At this point, I am adding a feature. I am adding code that will allow somebody to do something they could not do before, okay? That is a new feature that somebody has requested. That's value demand. And we can ship it, and somebody can experience that and go, yeah, this is what I wanted, or perhaps give us feedback that that's not quite what they wanted, but the idea is they can now do something they could not do before at a request. Failure demand is created by the organization not working properly. It is caused by a failure to do something or do something right. The most obvious form of failure demand is bugs, okay? Fixing a bug. Are you actually truly adding value? Well, I guess I'm allowing somebody to do something that they couldn't do before. I mean, they were supposed to be able to do it, but they couldn't do it. A bug is a shortfall, or to be precise, a defect is a deficit. We promised you this much, but you got this much. That shortfall is a bug. So you're now working to make up. So what do you do? I'm fixing a bug. That's failure demand. That's the most obvious form, but there's other forms. I'm sitting here scratching my head trying to work out what this 20,000 line function is going to do. Don't laugh until you see it, okay? Look at it, what is going on here? I don't understand. I mean, yeah, I get that it's a little bit over-indented, and there's an awful lot of other stuff going on here, and I really wish that the developer had really branched out and used variable names with maybe 2 letters or 3, perhaps. And so you're doing that. What's that? All of that time you're doing is rediscovery of lost knowledge. You're fathoming what is already there. You already have this. So why are you spending time on it? Because I don't understand it. That is failure demand. Failure demand is going to your colleague, like, I don't know what's going on here. Or I'm not going to change this because we don't have any tests for it. And all the rest of it. It's all of these other actions. It turns out that in a given 8-hour day for a commercial developer, probably at least 7 hours can be written off to failure demand. Most people are actually living in the past. Oh, I want to create the future, but I only have 1 hour a day to do that because everything else is pulling me back with the decisions and the weight of the past. And this is the point. There's never enough time to do something right, but there's always time to do it over. This is Melvin Conway. He wrote this in 1968. It turns out that we haven't really come up with any new ideas. The challenge here is time. And what do we know about time? Well, we've already discussed that. Time is money. Another way, taking a kind of classic paper from the late 1990s in the patents community, a paper called Big Ball of Mud, a term people often use to describe their legacy code. Brian Foote and Joe Yoder. If you think good architecture is expensive, try bad architecture. This is, in fact, I've come to use this as a kind of a template for anything that takes effort. If you think good thing that takes effort is expensive, try bad thing that takes effort. You can substitute lots of things here. Code quality, architecture, testing. There's a lot of things that substitute there. And you suddenly realize, oh, we thought that we had an option of not ever having to pay, but it turns out the bill comes due. And sometimes it comes with a whopping great interest rate. So, just to highlight that there's nothing new under the sun, this is a kind of classic book, and clearly you can almost kind of carbon date it based on the cover image and the title, Mythical Man Month, somewhat gendered. 1975, I think this book was published, 76, 77, around then. Fred Brooks, the late Fred Brooks, sadly. A lot of really good insights here. And we might question here in 2023, what is the relevance of this book? This is a book that was first published in the 1970s about a project in the 1960s. It received a second edition in the 1990s, which is this one, that included additional essays and material that he'd written in the 1980s. This is all before the year 2000. Could it describe anything of use to us here in 2023? Yeah, well, let's just see how we do, because it turns out that what the value of this book is that Brooks is talking about people. It turns out that there's a lot in software that's changed, perhaps not as much as we think, but people have not changed. And he asked this question. This is a question he poses in 1986, and it feels fresh today. How much of what software engineers now do is still devoted to the accidental as opposed to the essential? The things that we actually need versus the things that, oops, it happened. The things that we shouldn't have to have, the things that are non-essential, to use another term. Now, he makes another observation, which I think is quite important, elsewhere in the book. Because the design that occurs first is almost never the best possible, the prevailing system concept may need to change. He actually wrote this in the 1970s. He's basically saying, you're not going to get it right first time. That's fine. You may need to change your underlying concept of your system and therefore your architecture, even your whole approach and your choice of technologies. That's fine. But he also makes another observation. Flexibility of organization is important to effective design. He's actually saying the way that you organize yourselves and people around you, whether you're stuck in an office, whether you're working from home, whether this is commercial code, open source, the idea is that some flexibility, some adaptability, let's do the thing that humans do quite well, is necessary. But he got this, he was inspired originally by the idea of organizational structure mapping onto software. I just mentioned Melvin Conway. He's perhaps best known for Conway's law. And that's where this diagram comes from. That's actually where that quote before came from. Melvin Conway is very much known for Conway's law, although I'd like to point out that he's also done other things, like in the late 1950s, he invented a little idea called the coroutine, which has apparently enjoyed some popularity coming back in the last 10 years. What I love is, it was just earlier this year, I was Googling around for some stuff. I wanted to write a presentation on coroutines in different languages, and I came across a website. Hey, there's this new idea, coroutines. Let me tell you about it. It's a really fresh idea. It's just like, oh man, this is so old that it feels new. Yeah? We're back in rockabilly era here, okay, late 1950s. And Conway's original thesis is that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. He's basically saying the way that you communicate with other people will influence the way that you build your software. When you put it like that, it was like, well, yes, of course, because that's how humans work. The very word itself, communication, comes from the Latin communis. It's togetherness. That's the whole point of the word communication. It's about togetherness. That's what community comes from. Communication is the way that we choose to trust or not trust. Oh, I don't trust them. Put an interface there. Put a whopping great isolation layer. Yep, lots of modules between me and them. Okay, good. I feel safe now. This is my blanket fort for my code. I trust you, so you can look at my modules, and I'm absolutely fine. We can share code and we can operate on the same trunk and all the rest of it. But them, barriers of defense. That's kind of what he was saying there. But it goes further than that. He also made another observation, which again feels dangerously prescient. This is 1968. The structures of large systems tend to disintegrate during development. I love this. When I was rereading this, it's a very short paper. We don't use this vocabulary enough. I want to talk about code bases disintegrating. I think this is because we talk about integration, we should talk about disintegration. It's the natural opposite. Yeah, I think many of us work in disintegrated environments when we sometimes first arrive. Qualitatively more so than with small systems. Now, here's an interesting observation. There's a graph here. It's got lines. It goes down. It's got a logarithmic scale on both sides. It basically shows the productivity of developers with respect to the size of code bases. And this is all based on a modeling approach, a simulation approach, put together by Rob Smallshire. It's an absolutely classic. It's a classic blog post, which I didn't come across actually until I think the beginning of the pandemic, but he wrote it in 2014. Predictive models of development teams and the systems they build. Everybody should read this. It's really interesting. But Rob concludes. Basically, productivity is a function of code base size. Developers are dramatically less productive on larger bodies of code. But he doesn't just say this intuitively, which I think we all know. He actually demonstrates this. And code doesn't get big because we care about it. It gets big through neglect. Have you ever heard anybody complain about a legacy system? Oh, that legacy system is so small. It's so well formed. My God, I can read everything. I don't have to sit there thinking of which modules have I forgotten? Or I can see modules stretching to the horizon. It's like, oh, no, my complaint is, I understand everything. It's all within my mental reach. Not a thing, okay? The point here is this natural accumulation, exactly what Lehman was saying. Rob goes on to explore this, and there's some really interesting observations. Over time, what we see is the proportion of code written by the current team in a 20-year project. The current team working on it have only worked on, the people in the room will only have worked on 20% of that code. The other 80% is, who knows, is legacy. This is normal in this sense. He even comes up with this nice simulation to try and show you another consequence of this. He looks at a 7-person project developed over 5 years. You see the initial kind of inflationary phase, the initial rapid growth. But what's important here is these lines where the color shifts after this line. That developer has left the team. But importantly, their influence doesn't disappear overnight. It's kind of like an aftershock. That might not be the right metaphor, but sometimes it feels like it. Okay? The point is that your influence lives on afterwards, whether you like it or not. The decisions, the incidental decisions of you and others who were on that code, it lasts over a much longer period. We do end up programming in the past. The observation that Rob makes when thinking about Conway's law, he says the state of a system reflects not only the organization, but the organizational history and the flow of people through these organizations over the long term. What I mean is that the structure of the software reflects the organizational structure integrated over time. In other words, Conway's law is actually a time-based thing, not just a structural or space or communication-based thing. And some of the time we're communicating with the past, or the past is communicating with us. I mean, when we're communicating with the past, it's normally in kind of expletives. But occasionally there's a moment you go, oh, thank you, programmer who I never met. Thank you, past me. Thank you, whatever. That was a really good decision. But a lot of the time it's like, oh. I'm not saying you should be able to predict the future. As I said, we are always in the position where we are working against we're working with insufficient knowledge, incomplete knowledge. Now, there's another element here that we need to understand how people approach this stuff. And I've had a few people kind of like complain, oh yeah, the reason our software sucks is because we're doing agile development. It's like, well, clearly we've got misunderstandings about the word agile. Let's go and look it up in the dictionary. I'm going to use the concise OED because it's a little easier, because it is a usage dictionary. It's an adjective. That means it describes the property of something. It's an observation you can make on something. It's not a thing you do. You can't do agile. It's an observation. You can go, yeah, we're more agile than we were 6 months ago. That team is more agile than that team. Okay? It's an observation. It's not a thing you can claim without external observation. Able to move quickly and easily. Okay. If somebody says, yeah, our code sucks because we're doing agile development, might I suggest that you probably forgot the word after and? Because this is what most organizations end up doing. We're doing agile. It becomes a noun. It's quick movement. And, two things is way too hard. We're just going to go for quick. We're going to go for rapid. We're going to go for the word fast. What about easily? That doesn't matter. We're just going to do it fast and boldly. We're going to move fast and break things. Yeah, the revenue stream in the long term, for example. And what do you actually end up with? You end up exhausted. What you end up with is accelerated micromanagement. Now, you can call it agile if you like, but having hung out with various people in the agile community and been involved in that community, it's like, yeah, all that stuff, that's not agile. You've taken the words and done something very different with those words. And a really common one, this is the one that is most frustrating. Prioritizing business goals over technical excellence becomes the practice. Oh, we don't have enough time to repay our technical debt. We've been told to prioritize feature development, because apparently features do not depend on the technical structure that you've got. Features, it turns out, are made of magic. They are not made of code. Because if you understood that they were made of code, you would never say this. Because it must be something other than code. The developers do something with code, we don't understand what, and then there's magic, where the features come from. These are two different universes. Okay, this is Cartesian dualism taken to some kind of crazy extreme. What's the upshot of this? Well, you undermine the business goals by ignoring technical excellence. Now, why am I using the term technical excellence? It's a very specific term. It actually comes from the Agile Manifesto, which is actually very clear on it. Not perhaps in its original statement of values, but when you kind of click through the fold, continuous attention to technical excellence and good design enhances agility. There is no ambiguity here. There's no kind of like, hey, forget the technical stuff, just deliver fast and then become exhausted. It does not say that anywhere. It also makes another point. Simplicity, the art of maximizing the amount of work not done, is essential. Now, this is kind of true, and it's also kind of wrong. In other words, that's not the definition of simplicity. There are lots of different definitions of simplicity. Maximizing the amount of work not done is not a definition of simplicity. It might be a consequence of it, but I treat it as a separate value. Simplicity is essential, yes, and also maximizing the amount of work not done is essential. These are not identical, these are not equivalent terms, but they also draw us into understanding the relationship here. So what is the relationship we have a problem with? We keep talking about simplicity, and then somebody goes and creates a framework. And, oh yeah, but this will solve the problems in the future, because apparently you can predict the future, which is awesome. And if that's true, honestly, I'd suggest not hanging out in software development. There's way more interesting things to be doing if you can predict the future. But we can't predict the future. But we are very good at creating complexity. We do it out of a kind of fear, obsession. We also do it because we think we're doing the right thing. People don't generally do things because they think they're doing the wrong thing. We are responding to a genuine need. It's just perhaps that the way we've responded is not as effective as we thought it was. Promit Roy made this observation. As someone who ends up building a lot of architectural and infrastructure code, there's one thing I cannot emphasize enough. Do the simplest thing that works. Do not try to imagine future requirements or support ill-defined potential use cases. It will always change later. And then there's this huge pile-on of agreement. People like John Carmack going, yeah, it is hard for less experienced developers to appreciate how rarely architecting for future requirements applications turns out net positive. John Carmack id Games, Doom, Wolfenstein, all that stuff in the 90s. It's really interesting if you go back and look at his and Romero's practices for developing games in the 1990s. It's all about, don't worry about the next game. Don't worry about the future of this thing, okay? I mean, that doesn't mean screw it up. It doesn't mean make a mess of it, but make the present look good. Because if you make the present look good and you don't neglect it, what you're going to end up with is the future is more likely. It's a game of probabilities. But if you try and add the complexity to anticipate the future, you will make the future more complex. This is about deciding things. Gregor Hopper has this lovely observation, first law of architecture. Excessive complexity is nature's punishment for organizations that are unable to make decisions. So I edited this book, 97 Things Every Programmer Should Know, a few years back, and I had a number of very good contributions, but one of the ones I want to highlight here is, I mean, you kind of know where this is going with that title, from Klaus Marquardt, The Longevity of Interim Solutions. Oh, it's just a temporary solution. Oh, it's just an interim solution. I remember I used to have a client in Hong Kong, and one of the things that I enjoyed doing in Hong Kong was visiting a place called Stanley Market. And there's a sign. It's a temporary market, but there is a permanent, or it was a temporary market, there is a permanent sign to the temporary market. It's been there decades, okay? As Klaus observes, interim solutions acquire inertia or momentum, depending on your point of view, because they are there. They're ultimately useful, and they're widely accepted. There's no immediate need to do anything else. So the interim solution remains in place forever. Oh, but that's not the end of the story, because, of course, one of the things we know is constant in software development is change. If problems arise with that interim solution, it is unlikely there will be provision for an update that brings it into line with accepted production quality. What to do? Oh, no, we got this one. Oh, yeah. A quick interim update on that interim solution often does the job. Repeat as necessary. Now, this is neglect in action. This is the challenge that we accidentally stumbled into. This is maintenance. That whole point is what he's describing the absence of is maintenance. We tend to talk about it in another language. For example, refactoring. That's part of what should be considered maintenance. But when thinking about this, when looking at this kind of approach, if you've not come across commit strip, it's kind of up there with XKCD, the kind of things you should read. It's a lovely comic strip. On the left is your project manager. So will refactoring the code improve loading time? Developer on the right? Not really. Okay, will it improve security then? Nope. It's for browser compatibility? Absolutely not. So tell me, why is it always the same old story with you guys, wanting to refactor everything? I need to know. Because as devs, if we know we've left messy code, we can't stop thinking about it. When we wake up in the morning, at lunchtime, in the evening, when we go home, and when we're trying to sleep, it haunts us. Now, of course, refactoring is not just about dealing with bad code, but this is certainly a lot of people's kind of psychological kind of perception and experience of it. So when we're looking at this, we need to kind of think back to it's about maintenance. That's the original proper word. Maintenance takes effort. What happens when we maintain things? We discover things. It turns out, remember I said most of the knowledge you need to develop what you're working on today is in the future. Well, yeah, you're only going to get it by doing it. But it involves active, deliberate thinking and discovery. Deliberate discovery. You must go out with the understanding that you don't know everything, and you will be surprised, but also delighted, and you will act on it. There's another way we can actually summarize this. It's called design. Design is a process. It's not a moment. It's not a static thing. So I will leave you with this thought. Isabella Beaton, a slightly tragic figure of the mid-19th century, she wrote a book called The Book of Household Management, which I can tell you're immediately going to rush out and buy. It is still available, even nearly, well over 150 years on. But within it, cunningly, I mean, I say she's tragic, she died when she was about 30, but within it, she turns out to have been alongside Ada Lovelace, one of the early programmers, but cunningly she disguised all her programming advice as advice for managing kitchens. Clever disguise. There is no work like early work. Okay? This is how we want to think about the relationship between us and the code. It's an activity, work. It's an action. It's not an inaction. Clear as you go. Muddle makes more muddle. Modern kitchens still operate on this principle. We don't save time by creating a big pile of washing, if you've ever been stuck in that situation. Okay? We don't save time by not dealing with the issues that we can see. Of course, we can't see anything. Forgive yourself for that. But you can see probably quite a lot, and other people can. Okay? Take advantage of the collective intelligence of the people you're working with. They will be able to see things you can't. Use that. Not to wash plates and dishes soon after using makes more work. I think we need some plates and dishes metaphors, not just ports and adapters in software. So I'm going to close this with the thought from the author, Annie Dillard, given that we talked about time is money and our metaphor for it. That when we come to deal with these things, that often, as humans, we notice the big things. We're not as good at noticing the little things. And we are also not very good at noticing the absence. Okay? The absence of something is not something that we see. That is why there's a neglect. It's not because it's willful. It's not because we're stupid. It's not malice. It's just sometimes we have to be tuned to the right attention. And sometimes we have these big plans for the future. And then we arrive in the future and those big plans didn't happen. As Annie Dillard says, how we spend our days is, of course, how we spend our lives. Thank you very much.